Hello everybody. So I'll share a screen then so we can have a look at a short presentation. So my my personal subject area is marine geology and geophysics. I do quite a lot of physical geography underwater, so that's how I've ended up with this role in looking after this pathway. I just wish to introduce a few ideas that illustrate how physical geography and geology are very useful to each other. It turns out there's an enormous overlap between these two subjects. And physical geography is actually very important for geologists. So this is the high Himalayas. I'm sure you know, I'm sure you've seen these peaks before. And it's showing these giant glaciers which are eroding the landscape. And you have these very big flat areas of hillsides where large landslides have actually removed big chunks of the rock. Traditionally in physical geography, you will have been involved in making measurements in things like glaciers and rivers. It turns out they're actually very important to us as geologists. So if we see the next slide. The reason is that when erosion occurs in places like this, it's removing a lot of the weight from the landscape. These rocks are ultimately taken down into the Indian Ocean and the Bay of Bengal and so on. Removal of rock from the landscape takes a lot of pressure off the rocks underneath, and that allows plate tectonics to push up the landscape further. If it wasn't for erosion, plate tectonics would stop because it would ultimately be not possible to keep pushing up mountains indefinitely. So erosion, it turns out, is important for how the big thrust faults move. So when you think about earthquakes in places like India, well, ultimately they are connected to erosion and the physical geography process at the surface. This is some computer modeling by Chris Beaumont and others, illustrating all these processes occurring. It's quite complicated, but it illustrates how a mixture of physical geography, computer programming.
Sorry to interrupt, Neil. But I think we had a problem, and I think everybody's been blocked out. My internet cut out.
Your internet cut out?
Yeah.
Is it my internet, do you think?
No, it was mine. Leonie, everybody's back in the waiting room. Could you
okay.
let everybody back in?
Shall I start again?
Yeah, I'm sorry.
That's all right.
I think everybody's...
I think everybody's here now.
Okay.
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 So I wonder how much do you think you missed about?
I'm not sure.
I think it's okay. I think it's just continue. I think it's been happening.
Okay.
Yeah, sorry,
Right.
Neil, your presentation has been seamless, but I haven't been interrupted, so go ahead.
Okay. Sorry to interrupt.
Okay, it's all right. Well, I was just talking about the Himalayas and how recording the erosion of the landscape is important to geology, because removal of all this material that gets carried down into India and eventually into the Indian Ocean, this removes weight on the landscape, and that allows the rocks to be pushed up. Without erosion, the plate tectonics would stop because it'd be impossible to keep pushing the Himalayas up continually. As erosion removes weight from the landscape, it allows plate tectonics to keep pushing new material up, and that's why we see very old and deeply buried rocks at the surface. So this is all illustrated by this model by Chris Beaumont, which also illustrates the wide range of skills now in this subject area, a mixture of studying processes at the surface, metamorphic geology, understanding how rocks are, where they came from, and computer modeling. This is how the subject has changed over the last 20 or 30 years. So in the previous parts, you may have just interpreted things you saw in the landscape. Now it's become much more interdisciplinary, many different subject areas coming together to try to understand these things. Mountains are also important because for Earth's climate. It turns out, for example, weathering of certain rocks can extract CO2 from the atmosphere, and that CO2 ends up in the oceans and it gets turned into things like coral reefs and other carbonate deposits. So mountains are important for removing, for the global chemical cycle, can remove CO2 from the atmosphere and ultimately affect Earth's climate. It's an exciting subject because of a huge range of new techniques that have become available over the last 20 or 30 years. So, for example, whereas geologists are interested in dating sedimentary rocks, a physical geographer can date how long landscapes have been exposed to cosmic radiation. So when particles come in from outer space, they interact with other particles in the atmosphere and they can cause damage to the rocks, very tiny amounts of damage to the rocks. And by measuring that radiation damage and how it builds up over time, you can actually work out how long surfaces have been exposed. And this has made a huge revolution in our subject area. If you can date different exposures of rocks and you can date the sediments that are produced by erosion, you can quantify the whole landscape potentially. There have been big changes in computer modeling. So this is a model of a river network. We have ways of measuring topography much more accurately and with higher resolution than before. So for example, this is a big lava flow that happened in Kilauea, Hawaii in 2018. The US Geological Survey scientists have mapped out the topography, and they had previously mapped the topography. So by combining those two data, they were able to map out the thickness of the lava, where it was erupted from up here, eventually traveled down into and reached the ocean, and then some of it entered the ocean. So it's a fantastic time for working in this subject area. And as I say, there's an enormous overlap between geology and physical geography that we enjoy working between. Our modules, just to give you some thoughts, our modules allow you to pick a wide variety of pathways within a pathway, if you like. So if you're interested in mountains, for example, you can study structural geology, metamorphic processes, minerals, and then in the final year you could be, and in the geography, because we share our modules with the geography department, you could pick quaternary climates. And then in the final year you might be picking tectonics in Earth's oceans and continents. This is a module I'll be teaching. Or you could pick something completely at the other end of, if you had a good idea of an applied avenue for your study here, and you may have a good idea of what you want to do afterwards. We do have applied modules like remote sensing. It's quite useful. GIS is a very good module for getting jobs later on. And we have other applied modules within our own department. We have environmental challenges. So for example, problems looking at arsenic and waste disposal. So these are areas where there could be jobs, geophysical techniques as well. Now I did have another slide. I don't have such an idea of jobs, but I note that a lot of my past students have gone into things like looking at spatial planning. So GIS is quite useful for that. If you do this pathway, you would be able to go on to traditional geology jobs like oil and gas, hydrology, mining, and so on. Civil engineering. Geologists get involved in characterizing sites in something we call geotechnics. So what a variety of ways you can use this pathway. I'm going to stop sharing now.